Hi, my name is Jacopin. I work at the Center of Research of the French Military Academy of Saint-Cyr. This talk is about visualizing, classifying, modeling in-game data from the planning component of the artificial intelligence engines of 6 commercial first-person shooters. And that's it. So the talk is a package for game AI planning analytics, so I'll explain all that. Planning, AI planning, game AI planning. My name is Eric Jacopin. I work at the Center of Research of the French Military Academy of Saint-Cyr. The main difference with the US is that there is only one military academy in France, whereas there's quite a bunch in the US, and it's located in Brittany. Okay, abstract. So I describe that package I've been developing for the past 4 years as a package itself, but I've got plenty of functions for now 10 years. The objective is to analyze in-game data from the planning component of an AI engine, artificial intelligence engine of a commercial video game. And I also briefly address Mathematica package development if we ever have the time. So I begin with the goals of that work. So in terms of research, my primary goal is to characterize game AI planning so that game AI developers find it easier to use game AI planning in their video game projects. So as a researcher, it means that my questions come from game developers, not from me. Just I try to listen to them. I knock at their doors, and I do ask them questions. And from what they tell me and from the discussions, then I try to set goals for my own research. The objective for that package, there are many actually, but one side of game AI planning analytics is to visualize and classify. That's usual analytics, right? Visualizing, classifying, and modeling. I won't show you anything about modeling in game AI planning data. All right. Another side of characterizing game AI planning is to provide metrics for assessing the performance of game AI planning components in a video game. So think of it. Commercial games are extremely expensive. They now studios now spend hundreds of millions of dollars on only one game. And the idea is to, of course, reduce both the amount of money spent and the time there. So it's not business as usual, but project development as usual and project management. So the idea is to come up with metrics so that you can reduce both time and money on such huge projects. This presentation objective is to show the kind of visualization and classification and report on my experience, my sad experience on package development with Mathematica. Okay, so let me start with planning. What it is planning? So I just noticed that in this building, those two, that's the very first one of the two things here. That's a plan. Actually, in terms of psychology, cognitive psychology, that wouldn't be a plan, but let's say that's a plan because that's exactly what's happened in a game. You can see here goals, right? The stairs. It says, so use stairs, which means that you have to do a little processing there. Stair right here and stair right here. Let me go on that side. Stairs and stairs. And if you're here, right, there are two plans for you. Then walk, turn to left, walk, and then new stairs. Or there is no turn to right, which is very interesting. But walk, and then use that stair far right. Okay, so that's the idea of planning. That's more path planning than just action planning, because I had to explain those arrows and transform the goal, the stairs into a goal to put it in the format of what happens in a game. Another emergency exit plan. Okay, so you can see I'm on the third floor, so my room is right here. So it's on every door in every room. That's another plan. So plans currently are almost everywhere, right? This is a prospective plan. It should be in the future. Planning is about the future, but planning can be also about the past, right? If you want to explain what happened. All right, so game AI planning. Game AI planning, well, that's an artificial intelligence technique. It's been invented in 1968, which means it's almost as old as AI. Actually, the very first AI program, GPS, General Problem Solver, used planning, but at the time, the vocabulary wasn't there. But they used action, they used means-ends analysis and things like that. And 10 years later, the Stanford Research Problem Solver, Research Institute, I for Institute Problem Solver, was invented to produce plans, to build plans for a robot. So what do plans look like? Well, if you remember those evacuation plans, we had a 5-action plan: walk, turn to, walk, walk, and then use stairs. But in a game, it's more a plan like that: go to, inspect, and threaten. It means starting in a place, okay? You go to and you inspect. How do you do that? Well, when you arrive, there is what is called a smart object. You just download an animation into the character, and then that character inspects the area, and then he threatens the area for some reason. Okay, game AI planning. So remember that AI planning was invented, per se, in 1968. Game AI planning was born in 2005 when Jacopin, then a master's student at MIT and hired by Monolith Studio, decided to use strips in a game. At the time, the previous game, which was titled No One Lives Forever, was a hit, and they wanted to improve the AI again, to push it further, and they decided to use a planner to control the behaviors of non-player characters. That was the first time, so it's only been there, game AI planning, since 2005. So this very first game AI planner was called GOAP, Goal-Oriented Action Planning. And since there's been quite a lot of games using GOAP to control NPC behaviors. Okay? Another planning algorithm got implemented by Guerrilla Games. Guerrilla Games, so Monolith is in Seattle, but Guerrilla Games is in Amsterdam, Netherlands. They used hierarchical task networks to implement planning. I won't explain that, just give an example in a few minutes. So that's the example. Go builds plans from actions. Go to, inspect, threaten. Okay, so that's a plan. And go to is an action, inspect is an action, threaten is an action. And HTN planning builds plans from macro actions. So that plan, go to, inspect, threaten, you can see that as a patrol plan. So what HTN's planning does, instead of trying each action, find lower grain actions, go to, inspect, threaten. It tries coarse grain action, bigger grain actions such as patrol. And if this patrol action is applicable in the current situation, then it is decomposed in those small free actions. Okay, which games since 2005? So it's just a brief sum up of the games. So you can see the fear hierarchy here, Fear 2 and all these games. You can see that these games are mostly horror or combat games. They are first-person shooters, that's right. So let's see, Monolith, Just Cause 2 was implemented in Sweden, and Transformers by High Moon Studio in San Jose, Deus Ex by Eidos Montreal, and Tomb Raider was implemented by Crystal Dynamics in south of San Francisco. Okay, GOAP versus HTN planning, some video games using HTNs. So you can see the Killzone series here, and they stopped the Killzone series Guerrilla game, and Their last game is Horizon Zero Dawn, which I highly suggest to play. Horizon. Life is Strange and Horizon as well. Dark Soul, which is, I don't suggest you to play Dark Soul. It's a very difficult game. A Total War Napoleon is just for fun. It's a bad planner. And the very last, I'd say, very last game of the Dying Light series used HTN planning as well. HTN planning is slightly decreasing in the game community, game AI community, whereas GOP is widely used these days. Okay, so data. So usual things about data analytics, right? We collect, we extract, and we visualize, we classify, not classify in terms of, classify in terms of comparing, not in terms of learning, right? And modeling. Okay, so game analytics, what does it mean? You got generally a bunch of players, right? The idea is just to know why those players bought my game and they didn't even install it, right? There is these huge games servers, Amazon-like, Steam, for instance, and on Steam, the number of games per account is 70. So on average, people are playing at most 10 or 12. Right. I'm having 18 games and I'm playing 5 or 6 games. Okay. Okay, and then you crunch, and then you get two things: money. You explain why people are playing or not playing the game, and then you got heat maps just on the below. Heat maps telling the players where to put when you play sniper, where you should be, or where you should put your machine gun, or where you should throw your drones on the enemy, and all these things. Okay, so planning analytics, what does that mean? You got a plan engine inside of a game engine, which is which inside you also have an AI, artificial intelligence engine, right? You have a game state. Sorry, I'm going this way as well. How is game state defined? It's a vector of values. Distance. Too complicated. No. That would be distance to some of the characters only at some point. Within a radius, for instance. Okay, and short radius. Because what you have to know, please have in mind that's the time budget, because games are real-time systems. It's extremely important to have that in mind, right? Games are real-time systems, and the time budget, so everything is designed, it's a placement problem, right? How much time you give to your component, and the planning component can get at most 10% of a frame. So when it's 30 frames per second, it means about 33 milliseconds for one frame on screen, and 10% of that is about 3 milliseconds, okay? But planning is just one part of AI, right? There is path planning, there is line of sight, there is threat detections, and all these things. So it's again about 10% of those 3 milliseconds, which means it's 0.3 milliseconds per frame. That's quite a lot. All right. Planning analytics. So on average, what the game community is doing, and there's quite a lot of money on that, is maximizing the value of player data, right? These days, you have online games with millions of accounts and millions of players. So we want to know where they die. We want to know where and what they do and why. We're trying to give actions to interpret their sequence of move, to detect their intent and what they want to do. And we're trying to maximize that and offer them, actually not offer them, but getting some money from that. Okay? And what I want to do is just the thing on the side, it's maximize the value of planning data, right? So over the years, I've been able to get some data from commercial games. That's something which is extremely difficult to do because games are IPs, or intellectual properties, right? So it means when you knock, for instance, at Monolith Studio, it means you end up 8 months after in an office in Hollywood, and you have a lawyer in front of you, and he explains everything that you shouldn't do with the data that they might be giving you. So it's quite strange, but it's quite a fight. To get some kind of data, it takes approximately 2 years. So when you first knock at the door and you get some data, it's been 2 years, mostly, right? Okay, so what does it look like? I'll show you the data. Those two, I got several, but I give you the first two only. Okay, here is Killzone 3, data from Transformers. Okay, so you can see it begins with a timestamp, then the name of the NPC, so you can see what it looks like. What is this one? I just don't remember. Okay, you can see the plan. The plan was, remember, active plan. You can see it's just a move, all right? It's probably, that's a drone. That's a drone, okay? And 1032, 1033, 1034, and so on is just numbers of nav meshes so that the drone can move over the player, okay? So you can see that the timestamp here is a big number. It's because the number of ticks per second is somewhat very strange. Actually, Guerrilla Games is a Sony studio, so they're producing games on PS3, PlayStation 3, and they produced games on PlayStation 3 and PlayStation 4, which means there was no way at all, that one was on the free, no way at all to export files. So they did a very specific Linux version of the game, and the only reliable real-time clock they were able to have had that number of ticks per second. So you can see the differences between the data, which means it's some kind of guerrilla analytics as well. When you get some kind of data, you say, okay, I like something more, this and this. For instance, I like the NPC location, and then you don't get it. So in the next one, you can see the NPC location. That's the triple of numbers right here. But you can see that this time the timestamp has nothing to do with the previous one. And I've included this data because I think it's quite fun that someone didn't make a description for this value. So there are bugs in software.
Another question.
Yeah. Yes?
Are Cartesian coordinates within the game frame?
Which one? This one?
Those three values.
Those three values are the position x, z, y of that character in the game.
Cartesian coordinates.
Yes. I'll say yes, but I'm unsure. Because it might be that there might be several origins.
There's an air traffic control.
Yes, of course. Oh, yes. Oh, yes. Okay, more data again. So if you load the package and you load the files from the game, then you can do some kind of planning analytics. So I can speak forever. I was in IDOS Montreal last week and I spoke all day. So on those kind of data. So if there's something you like the most, I can speak on something more and less on something else. Which one will you like? If you have no idea at all, I'll pick up one topic. Actions, cost and usage. That's it? All right. So let's go actions, cost and usage. Action cost. I'll begin with action cost. All right. So action cost. So strangely, you can see that, so action costs. Why do you have action costs in game? So the idea is just to attach a number to each action so that the search for the plan will be something like find the least cost plan. Okay, you want to achieve a goal, all right? So you can walk there, okay? And walk there will be costly for some reason. Or you can fly there, and it might be even more costly, and then adding the cost of the actions, then you'll find a cost for the plan, and then you'll sort out all these costs, and you'll find the least cost plan, all right? So you can see here how it looks like. That's the cost distributions for Fear, Shadow of Mordor, and the Tomb Raider games. So you can see that they look the same, right? These games have, the first two on the left have been done by, by the same studios. But the second, Shadow of Mordor right here, and the last, Tier 11, which is Tomb Raider, were designed by two different studios, and the cost distribution is the same, right? That's Tomb Raider, which means it's one character in third-person view, and it's the Tomb Raider series, and Shadow of Mordor, so it's your character against only a few, and in Shadow of Mordor, it's your character against several tens of NPCs, right? But anyhow, the costs are the same. All right, action cost versus action usage. That's an interesting one. Okay, I'll stop there. Okay, first, no, I don't take this one. I'm sorry. Yes, Shadow of Mordor. So I take this one, and you can see, so what's on the x-axis? The x-axis is action usage, okay? So one action appears, so you take all the data I have, and one action appears about 20% of the time. This one, right? The one on the far right, okay? And the action cost, you can see that the action cost is about 3, right? So they had this, this question for me, discussing with them. They said, Eric, we tried to tweak the cost, the action cost, so that some actions appear more often on screen, because we think that some action is more important for the player than others. Could you check that the least cost actions appear more often on screen? Well, obviously, that's not the case, right? You can see very costly actions here, okay? And you can see least cost actions, and they're less used than those actions right here, okay? And that's, again, the case for this action right here, okay? It's 2 times more expensive than this one, and this one is less used than this one. Okay, it's only 7% of the time and 5% of the time. But apparently, action cost, you cannot tweak action cost to modify the player immersion and experience. You tweak action cost only for the search for a plan. That's all what you can do. Okay, could show you.
Just one exception.
Yes.
I mean, there was only in one case it was just the second left rightmost and third rightmost that should be in different order. Right, those are.
Oh, no. This one as well. This one should be there.
Well, yeah. So little things like that make it. Yeah. Okay.
And this one should be there as well. And those ones should be somewhere here.
Does that really make a difference in terms of the game? You know, the way the game works and the way the players experience it.
Yeah.
Little things like that.
Yes, it does. Actually, it does. It does.
It's weird.
Yeah, I know it does. You have to think that a game designer is somebody constraining, inventing patterns, right? He invents patterns of interactions between the player and the game, right? The level designer just design the level so that those patterns can occur at some point during the level, and then they're implemented. Spawning of NPCs is implemented by the game programmers, but it's extremely precise, right? For instance, first test of the level, it's the game designer who plays the level. If he doesn't see what's on the game design document, he's going to be really mad. Really mad. So, and it's real different for everyone just to please the kind of patterns which was designed for the spirit of the game. You know, that's when you say a game is violent, for instance, take Rage, by id Software. It's one of the most violent game I know. I mean, you think Doom is violent, it's game id Software as well, Doom. Doom is violent, but no, it's not the case. Play Rage, and then you'll see. Well, how do you implement that violence, violent experiments, violent immersions, all right? So think of it, play Rage, play Doom, and then you see exactly same id Software game, right? But Rage is, it tries to eat you, really. It's a dangerous game. Okay, my belief anyway. All right, so I'm gonna show you something more. I'm gonna, yes, okay, action cost, cumulative actions, plant stability. Oh yes, plant stability, yeah, I'm gonna, no, too complicated. For plant frequencies, let me show plant length. On plants, oh, on NPCs, I'm sorry. On NPCs, what, session casting. What does it look like? What does a level look like? Okay, it doesn't want to show me the session casting? Okay, that's it. Okay, so here is a session casting, right? So what does it mean? That's the session for Killzone 3, the 13-minute I had. So a dot right here is represent a plan at some point in the game, okay? And one line represents, so a series of dots on one line represent an NPC. So on the y-axis, you got NPCs, and you got time on the x-axis. So what you see here is exactly what is designed in terms of level and patterns of interactions, right? You walk, you encounter drones, and then you walk, it's kind of cool, and then you fight, and then suddenly you walk more, and then enemies are spawned, and then maybe you take a lift or an elevator, or you walk even more, and then enemies again. That long yellow line is a sniper, very difficult to kill. And a very long red line is your AI companion. There are some AI companions from time to time in the game, and I want to show you that one, those two, if I may. All right, that's from, I've selected it. AI companion, it means it helps you. It suggests things to do for you. No, not screenshot. It talks to you. Oh, okay. Or it does things, and then you play and say, where is it? Oh, it's here. What is it doing? And then you suddenly realize he's kind of doing some kind of problem solving. But it's up to you to do it or not. Help him. Yeah. So what are these useful for? These may be useful for that. So I've shown you those this very long red line on the previous session casting. So if you see and tell you it's an AI buddy, so those two lines, orange and green, you'd say, well, these are AI buddies as well. No, they're rats. Okay, that's a bug. Okay, they're rats. If you encounter in tunnels rats. If you don't kill them, well, they've just forgot to despawn them, to remove them. You get out of the tunnel and you keep walking. They're 2 kilometers away from you. There's just no way for you to see those. Well, they just forgot to despawn the NPCs. So that's a way to find also bugs in the game.